In this video, we're going to learn how we can calculate the slope when we don't have the graph of a line in front of us. All right, probably the most basic way to find the slope of a line is to find 2 points that are on that line. And then on the graph, you can easily calculate the vertical rise and the horizontal run, and then you simplify your ratio. But what do you do if you don't have a picture of the graph? Well, it's still possible to find the slope even without having a graph. There's two different methods that we're going to look at in this video. The first is what I call the table method. If you are given a table of values, then the first thing that you need to do is determine the independent variable, which is always the x coordinate, and then you need to determine the dependent variable, which is the y coordinate. And it's important to remember that for slope m, you do the vertical rise over the horizontal run, or delta y over delta x, the change in your y values divided by the change in your x values. All right, so in your table, all you simply have to do is calculate the change in your y values, which is the rise, and then you calculate the change in your x values, which is the run, and then you use these values to set up your ratio and simplify if necessary. This will be your rate of change, which is also the slope of the line. So let's look at that in our first example. All right, the table below shows the number of raffle tickets purchased and their corresponding prices. All right, so here we've got the number of tickets, and this was the cost of those tickets. And we have to determine the independent variable and the dependent variable. Does the number of tickets depend upon the cost, or does the cost depend on the number of tickets? Well, the independent variable is going to be the number of raffle tickets because you can buy as many tickets as you want. All right, so that's your independent variable. The dependent variable is going to be the total cost in dollars. The total cost depends on how many tickets are purchased. So, what we're going to do is label each column with the appropriate variable. The independent variable, the number of raffle tickets, that's going to be our X, and the total cost, the dependent variable, is going to be y. Now what we're going to do is find the change from row to row. We'll set up our slope ratio, and again, we'll simplify if necessary. So let's start with the x values, the number of tickets. I'm just going to calculate how much it's changing from row to row. How much is the number of tickets changing? To go from 2 to 4 tickets, I had to add 2. To go from 4 to 8 tickets, I added 4. To go from 8 to 10 tickets, I added 2. Now I'm going to find the change in my Y values, which is the total cost in dollars. To go from $1 to $2, I added 1. To go from 2 to 4, I added 2. To go from 4 to 5, I added 1. And now what I'm going to do is look at the rate of change from row to row. So again, your slope m, your rate of change, m equals delta y over delta x, your change in y values over your change in x values. And if I start with the change in y values over here, to go from 1 to 2, I added 1. My change was $1, and my change in x, my change in raffle tickets, was 2 raffle tickets. So my slope m here is 1/2. From the next row to the next row, again, m equals delta y over delta x. This time, the change in the y values from 2 to 4 was a change of 2, and the change in x's from 4 to 8 was 4. So the slope m is 2/4, which can simplify down to 1/2. And then in the last row, m equals delta y over delta x. The change in y values to go from 4 to 5 was 1. To go from 8 to 10 in the x's, that was a change of 2. M is 1/2. All right, so that can't simplify. And notice that the rate of change was the same in all three places. So the slope, or the rate of change in this table, m equals 1/2. We have two different tables here. We're going to find the slope, or the rate of change, in each table. All right, for this table on the left, all right, this column shows the number of balloons, and then this column shows the total cost of the balloons. So somebody is ordering balloons, and we want to know first which is the independent and which is the dependent variable. Does the number of balloons depend upon the total cost, or does the total cost depend upon the number of balloons? Well, we can get as many balloons as we want. So that's going to be your independent variable x. The total cost of those balloons is dependent, y, on the number of balloons that you get. All right, so this is the dependent variable. We're going to figure out what the change is from row to row. So if we look at the change in x's first from row to row, 2 to 4 is an increase of 2, 4 to 6 is an increase of 2, 6 to 8 is an increase of 2. All right. Then we'll do the same thing in the y's from row to row. All right. From 6 to 12 is an increase of 6. 12 to 18 is plus 6. 18 to 24 is plus 6. And so notice that the change in the x's is constant every time. The change in the y's is constant every time. So for the slope m, all right, again, we're doing delta y over delta x. Well, the change in the y's every time it increased by 6. The change in the x's every time it increased by 2. We get 6 over 2, which is 3 over 1, or 3. So the slope of this table, the rate of change, m equals 3. For my second table, they're just labeled x and y, so I already know that this is the independent variable and this is the dependent variable. Let's find the change from row to row in each of those columns, I should say. In the x's, -2 up to 0 is plus 2, 0 to 2 is plus 2, 2 to 4 is plus 2. In the y's, 8 to 0 is a decrease of 8, so minus 8, -8. 0 to -8, minus 8. -8 to -16, minus 8 again. Okay, so the x's are always going up by 2. The y's are always going down by 8. For the slope m, delta y over delta x. The y change is always a decrease of 8. The x change is always an increase of 2. -8 over 2 is -4 over 1, or -4. So the slope of this table, m equals -4. Another method that I can use to find the slope is by calculating the slope from 2 points that are on the line. And so we're going to start off with a graph to show you how this works, but then in the later examples, we're going to take the graph away, and you're going to learn how you can get the slope if you know just 2 points that are on the line. So here is a graph of a line. The line is increasing as we move from left to right, so the slope here is going to be some positive number. And I know that the 0.35, which is right here, and the 0.1211 right here, those are 2 points that are on the line. What we're going to do is use those 2 points, and we're going to do a few things with them. The first thing we're going to do is calculate the change in x, which is the horizontal run between the 2 points. So I'm going to start at the leftmost point, and I'm going to go horizontally right until I end up right underneath of my second point, which gets me right here. And if we count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right that we moved. Okay, so the horizontal run in this example is going to be a positive 9. The next thing that we're going to do is calculate the change in y, which is our rise between the 2 points. So I've made it here, and now I have to count up until I get up to the second point. So from here, I'm counting up 1, 2, 3, 4, 5, 6 units, and that ends up being my vertical rise. Okay, so what if I didn't have this picture in front of me? Well, I could still calculate what the change in the x's is and what the change in the y's is by using x2 minus x1 and y2 minus y1. Now, what do those mean? Well, I'm going to call 3, 5 point number 1 because it's further to the left. I'm going to call 12, 11 point number 2 because it's further to the right. And even if I didn't know which one was further to the left or to the right, that's the first one, that's the second one. So this will be 0.1 and this will be 0.2. I'm going to use the x values from my 2 points, okay? 3 is the x value of 0.1, so this is x1. And 12 is the x value of 0.2, so this is x2. If I do x2 minus x1, I'm doing 12 minus 3. 12 minus 3 is 9. I can do the same thing with the y values now. 5 is the y value of 0.1. 11 is the y value of 0.2. And so if I do y2 minus y1, I'm doing 11 minus 5. 11 minus 5 is 6. And so it's possible for me to calculate the vertical change and the horizontal change by using these values. Now I'm going to calculate the slope of the line by substituting them into our slope formula. Slope is the rise over the run, or the change in y's over the change in x's. Okay, well, the vertical rise, the change in the y values, we went up by 6 units. The horizontal run, the change in the x's, we went to the right 9 units. And now I'm going to simplify that fraction. Each number is divisible by 3, and that's going to give me 2/3. And so the slope of this line M is going to be 2/3. Letter D says, illustrate your answer from C, 2/3, on the graph by plotting additional points. Remember that the slope tells you how to get from point to point on the graph. All right, so if you start on a point, to get to the next point, you're first going to rise 2 and then go to the right 3. So up 2, right 3, up 2, right 3. Let's show that. Here we are on 3, 5. If we go up 2 and right 3, we get to this point on the graph. If we go up 2 and right 3, we get to this point. If we go up 2 and right 3, we get to 12, 11, which was one of our other points. And again, if we go up 2 and right 3, that gets us to this point. So the slope always tells you how to get from point to point on your line. What we just illustrated in the previous example is our slope formula. A line that passes through the points x1, y1, and x2, y2 has a slope given by the following. All right, to calculate the slope m, the rise over the run, you need to find the change in the y values, which will be y2 minus y1. And then you need to find the run, you need to find the change in x values, x2 minus x1. All right, so these will be the coordinates of your first point. These will be the coordinates of your second point. Let's use the slope formula and calculate the slope of lines that passes through the given points. I don't have the actual graphs in front of me, but I do know that the line passes through each set of points in these examples. So let's start here. I know my first line goes through the points negative 2, 1 and negative 2, 7. To calculate my slope m equals delta y over delta x. And delta y is y2 minus y1. Delta x is x2 minus x1. Since negative 2, 1 is my first point, I'm going to call this x1 comma y1. And since negative 2, 7 is my second point, I'm going to call this x2 and y2. All I'm going to do to figure out the slope is substitute these values into this formula. Okay, so let's start with the change in the y values. All right, well, y2 is 7 minus y1 is 1. Now for the x values, x2 is negative 2 minus x1, which is also negative 2. And now I'm going to evaluate the numerator and denominator. 7 minus 1 is 6. Negative 2 minus negative 2 is the same as negative 2 plus positive 2, which is 0. And so we get a slope here, 6 over 0. The denominator is 0. That means our slope m is undefined. Okay, the slope of this line is undefined, meaning that this is a vertical line. Every vertical line has a slope that is undefined. All right, let's try that here with this example. The line goes through the points 2, 8 and 5, 3. All right, so this is point 1, so this is x1, y1. This is point 2, so this will be x2, y2. To find slope m, I'm going to do, excuse me, delta y over delta x. So I have to first find the change in y values. So I'm going to do y2 minus y1. y2 is 3, y1 is 8, 3 minus 8. Now do the change in x's. I have to do x2 minus x1. x2 is 5, minus x1 is 2. And now let's evaluate the numerator and denominator. 3 minus 8 is negative 5. 5 minus 2 is 3. So we get negative 5/3, and that doesn't simplify, and so that will be our slope. The slope of this line is negative 5/3. meaning that the line is going to be decreasing as we move from left to right. How about in our next example? We have negative 3, 6, and we have 7, 6 that the line goes through. This will be point 1, x1, y1, and this will be point 2, x2, y2. To calculate the slope, I'm going to do delta y over delta x. So I'm going to do y2, which is 6, minus y1, which is also 6. Then for delta x, I'm going to do x2, which is 7, minus x1, which is negative 3. 7 minus negative 3. Evaluate each of these now. 6 minus 6 is 0. 7 minus negative 3 is the same as 7 plus 3, which is 10. So we get 0 over 10, which is just 0. So the slope here is 0, meaning that this is a horizontal line. A horizontal line. Any line that has a slope of 0 will be a horizontal line because there is no vertical change. In our next example, the line goes through negative 2 comma 5 and 10 comma negative 4. This will be point 1, x1, y1, and this will be point 2, x2, y2. To calculate the slope, delta y over delta x, let's go ahead and figure out what those values are going to be. Delta y is y2 minus y1, negative 4 minus 5. Delta x is x2 minus x1, 10 minus negative 2. Evaluate your numerator and denominator now. Negative 4 minus 5 is negative 9. 10 minus negative 2 is 10 plus 2, which is 12. And so we have the fraction negative 9 twelfths. We can simplify that, though, down to the fraction negative 3 fourths. So the slope here, m equals negative 3 fourths. This line will again be decreasing as we move from left to right. In our next example, the line goes through negative 6, negative 1, and 6, 2. All right, so this will be point 1, x1, y1. This will be point 2, x2, y2. To get the slope, we need the change in y over the change in x. To do delta y, we do y2 minus y1, 2 minus negative 1. And then to do delta x, we do x2 minus x1, 6 minus negative 6. And if we evaluate these now, 2 minus negative 1 is 2 plus 1, which is 3. And to do delta x, 6 minus negative 6 is 6 plus 6, which is 12. And so we have 3 twelfths, which simplifies down to 1/4. So the slope of this line, m equals 1/4. It's a positive slope, so the line will be increasing as you move from left to right. And then in our next example, the line goes through the points 5, 8, and 9, negative 12. x1, y1, x2, y2. To get the slope, we need to do delta y over delta x. To do delta y, it's y2 minus y1, which is negative 12 minus 8. And then to do delta x, it's x2 minus x1, 9 minus 5. Now when we evaluate these, negative 12 minus 8 is negative 20. 9 minus 5 equals 4. And so we get negative 20 over 4, which simplifies down to negative 5 over 1, which is just negative 5. And so the slope of this line, m equals negative 5. And since it's negative, that means the line is decreasing as you move from left to right.